Lesson 17.4, we're going to do some extra examples just of solving by factoring. So for number 9 here, it says x squared minus 4 equals 0. If you remember, this is a difference of perfect squares. I've got the formula here for you to reference. So we're going to go x plus 2, x minus 2 equals 0. All right, so the order of the factors does not matter in this case. As long as you have same binomial, different sign in the middle, your middle terms will cancel and produce just two terms, which makes your difference of perfect squares. All right, so the zero product property says I can set each one equal to 0 and solve. So I'm going to have x equals -2 and x equals 2. So for the first one, we get x equals -2, x equals 2. And since I don't have a lot of space to write, make sure you pause this if you need to write it down, but I'm going to erase it and go to the next one. All right, so number 10, you can see, is 9x squared minus 1 equals 0. Again, 9x squared is a perfect square. 3x times 3x gives you 9x squared, and 1 times 1 gives you 1. So again, this is a difference of squares. So I'm going to have 3x plus 1, 3x minus 1. That's going to equal 0. Again, remember, 3x times 3x is 3x squared. Minus 3x plus 3x cancel your middle terms. 1 times -1 gives you the -1 on the end. So just a quick check, never hurts. All right, set each binomial equal to 0. Subtract 1. 3x equals -1 divided by 3, which is -1/3. And here I'm going to add 1 and then divide by 3. So x can equal 1/3. So this one's going to be x equals plus or minus 1/3. And if I put the plus minus here, that represents the two different signs. So again, if you need to pause this, write it down so that you have an example. But I'm going to move on to the next example here. All right, so number 11 is 4x squared plus 16x plus 16 equals 0. This is going to be the second formula here. This is a perfect square. This is also a perfect square, and this is twice my middle term. Now, if you want to do it as 2x plus 4, 2x plus 4, and that equals 0. Using the zero product property, we're going to set each one equal to 0 and solve. And then when I do that, you're going to see that you get the same 0 twice. So what that means, and we'll talk about this a little bit later, is that when you only have one unique answer, the parabola's vertex will be on the x-axis. So for number 11, we're going to get x equals -2. All right, let's do one more real quick. I'm going to do one of the later ones because I want to make sure that we do one that you have to do a little bit more to. You have to do more steps to solve. So let's look at number 18. So let's look at this one right here. So we're going to have 25x squared minus 20x minus 5 is equal to -9. All right, so the first thing I want to do is add 9 to both sides because I need to have it equal to 0. So I'm going to do 25x squared minus 20x. -5 plus 9 is +4. All right, I can see that this is a perfect square and this is a perfect square, and because the negative in the middle, I'm going to use this last formula here. So I'm going to have 5x minus 2, 5x minus 2 equals 0. And again, you can check this quickly. 25x squared minus 10 gives me negative 20, and negative 2 times negative 2 gives me 4. Again, because this only has one unique solution, that means the vertex will fall on the x-axis. I don't know why that line went through there. Let me try that again. All right, so x equals 2 divided by 5. All right, so that's the last one here. X equals 2/5. All right, so let's move on and look at a couple more. All right, so these say factors. So this one is not an equation. If you go back to the previous page, these all have an equal sign. These are all equations. So we're solving and finding the zeros. For 31 through 34 here, these examples, you're only factoring. So let's start with 31. 27x to the 4th minus 3x squared. All right, when I see 27, I think of multiple of 3. So 27 is 3 times 9, and what we're going to do is just factor out that 3 as my greatest common factor, but also notice that I have x to the 4th, which is x times x times x times x. And then this one has x squared, which is x times x. So both of these have an x squared in common. So when I factor out my greatest common factor, part of that is a number and part is the variable. So you have to do both number and variable to get the greatest common factor. So 3x squared times what gives me 27x to the 4th. So that would be 9x squared. And then 3x squared from 3x squared is just negative 1. Now you do have to have that placeholder. If you don't have the placeholder, it would just be 3x squared times this would give you the first term, but you wouldn't have the second term. So when you distribute, you have to get back what you started with. So you have to have that negative 1 as a placeholder. Now, perfect square, this is a difference of perfect squares. Bring down your greatest common factor, same binomial, different sign in the middle. So when it says completely factor, we stop with the factors. When it says solve, you set the factors equal to 0 and solve. But in this case, it just says to factor. All right, let's look at one more. So let's look at number 33. So we have 100x cubed minus 36x. And I'm thinking of what is the biggest number that I can factor out of both 100 and 36. And 4 is coming to mind. So I'm going to do 4. I also have x cubed and an x. So I'm going to pull out an x. And then 4 times 25. 4 quarters is $1. So 4 times 25, x squared. And then 4 times 9 is 36. So minus 9. Now, since I pulled the x out, this one no longer has an x. Okay? All right, so 4x times 25x squared, yes, that equals 100x cubed. 4x times negative 9 equals negative 36x. All right, perfect square, this is a difference of squares. 4x, same binomial, different sign in the middle. 5x plus 3, 5x minus 3. So this is your complete factored form. All right, I hope this helps. If you have any questions, let me know.